whenever we are writing A1 union A2, that means we are saying the events either A1 is happening or A2 is happening. In symbolically, we are writing by A1 plus A2. Fine. Now I am giving one example. Suppose, uh, throwing a die, okay, throwing a die. And suppose A1 is an event such that A1 is given by getting event phase, and A2 is another event getting multiple of 3 of 3. Can anyone tell me what is the value of A1 intersection A2 and what is the value of A1 union A2?
Sir, 3 and 6.
6.
3 and 6.
So
6.
6 होगा सर, A1 and A2 6 होगा सर.
6 and 3.
What is the value of A1 intersection A2?
6.
6. And what is the value of A1 union A2? What is the value of A1 union A2?
Sir,
अरे यार, यूनियन तो कुछ भी हो सकता है
2,
सर.
4, 2, 4, 6. 2, 4, 6.
2, 3, 4.
2, 3, 4.
4 6.
Exactly. So think about it. That A1 is an event that said getting event phase, and A2 is an event that multiple of 3. So multiple of 3 means only the numbers 3 and 6, correct? And getting even number of base, that means 2, 4 and 6. This. So if you are saying A1 intersection A2, that means you are talking about only the element 6. If you are telling A1 union A2, that means you are telling 2, 3, 4, 6. That's the difference that you feel. And I mentioned that whenever I am writing A1 intersection A2, that means I can denote it by A1 A2. In this format, I can denote. Whenever I am writing A1 union A2, that means I can write it A1 plus A2. That thing you have to remember. See. That A1 intersection A2, we can also write by A1 A2, the example that I have given. And that is A1 union A2. That means at least one of the events, A1 union A2, that we can actually write A1 plus A2. Then the event that the corresponding A1 that is there described. I have also described. Now it comes disjoint or the mutually exclusive events. Disjoint. All these terms you have to remember very carefully. Disjoint or mutually exclusive. Mutually exclusive. Disjoint or mutually exclusive events. What is the meaning? That means, suppose A1 is an event and A2 another event. So we are going to say that A1 and A2 are disjoint event if A1 intersection A2 is equal to 5.
0.
Okay. If A1 intersection A2 is equal to 5, then we are saying it's a disjoint event or the mutually exclusive event. Giving an example. Suppose you are throwing a die. Okay. And suppose A1 is an event that event phase come, and suppose A2 is another event such that odd phase come. Can anyone tell me what is the value?
0.
Sir, 0, 5.
0. 5.
No, it's a 5. Okay, it's a 5. It's a null set, 5. So A1 is an event that is event phase come, A2 is another event such that odd phase come. So obviously event phase means 2, 4, 6 and odd phase means 1, 3 and 5. So A1 intersection A2, that is actually 5. So I can say A1 and A2 are disjoint event. Okay. Now the definition comes, that is called your so-called pairwise disjoint. pairwise disjoint event. What is pairwise disjoint event? I am telling you. Suppose pairwise disjoint event. Pairwise disjoint events. Okay. Pairwise disjoint events. Suppose you have A1, A2, AN. So n number of events. Anyone want to join? Somebody please send the Jambo. Okay, that you share. A1, A2, AN. Suppose n number of events you have. Then I am going to say that the events A1, A2, AN are said to be pairwise disjoint events. So A1 to AN are said to be pairwise disjoint. Pairwise disjoint. If, okay, AI intersection AJ is equal to phi, such that IJ belongs to 1 to up to n and I not is equal to j. So is the definition clear to all? Please tell me. Is the definition clear to all?
No,
Am I
sir.
audible, students? Yes. So can I take this A2 intersection A2? Can I take this?
No, sir.
Can I take this? No. Yes or no?
No, sir.
No, because I have mentioned I not is equal to j. Ij runs from 1 to n, but I not is equal to j. So therefore, you can take like this A2 intersection A5 that you can take. Okay. So AI intersection AJ is equal to phi. This should happen. Then only you can say it's a pairwise disjoint event. See the definition. Let A1 into AN n number of events such that AI are said to be pairwise disjoint if no two events have common event points. That is, AI intersection AJ is equal to phi and I not is equal to j and IJ belongs to 1 to n actually. So I am giving one example. Just take.
Sir,
example.
pairwise.
Tell me. Pairwise means
Sir,
you can
pairwise
like
disjoint events. Sir, pairwise disjoint events and disjoint events में क्या difference है?
exactly pairwise whenever you are taking the disjoint events, you are just taking two elements or two events. Am I correct? Whenever you
Yes,
are
sir.
taking disjoint events, you are taking only two events. Am I correct? Such that
Yes, sir.
A1 intersection A2 is equal to phi. But whenever pairwise, I am telling there are n number of events. Am I correct?
Yes, sir.
That is more than two. It may be two, but it may be more than two, means 10, 20 like this. So I am giving example. That is the difference. Come to this example. Suppose you are suppose tossing two coins. Suppose tossing two coins. Okay. Now, what is my event space? Anyone?
Head, head,
Tail,
tail,
tail
tail,
head,
head, and tail, tail.
and nil tail.
Tail. Very good. So ace is becomes head, tail, head, and tail. That is the event space actually. Suppose I am denoting A1 is equal to head, A2 is equal to tail, and A3 is equal to head, tail, head. Can I say AI intersection AJ is equal to phi for I not is equal to j and IJ belongs to 1, 2, 3. Can I say this?
Yes, sir.
Yes, sir.
So
Yes,
that
sir.
is the case that A1, A2, A3 are pairwise disjoint event. You can check that A1, A2, A3 are pairwise disjoint event actually. Okay. Now the definition is next comes the exhaustive events. Now the definition comes exhaustive events. Exhaustive events. EXHAUSTIV. Exhaustive events. Exhaustive events. Suppose there are n events. Suppose A1, A2, AN. So there are basically n number of events. Suppose there are n number of events. N number of events. So the events A1, A2 up to AN are said to be. So the events A1, A2, AN are said to be exhaustive events. Are said to be exhaustive events if any of the event definitely occurs. Any of the event must occur. That means that word I can write it also S is equal to A1 union A2 union A3 and so on. Okay, so therefore if I perform some observation, then either A1 will happen or A2 will happen or A3 will happen or AN will happen like this. Therefore I can write S is equal to A1 union A2 union A3 like this. Observe. Two or more events are said to be exhaustive if at least of the necessarily occurs. At least any of them necessarily occurs or must occur. And in other words, we can say A1, A2 are said to be exhaustive if A1 union A2 union A3 is equal to S. Giving example. Come to the previous example, this example. Suppose tossing two coins. Suppose I am writing S is equal to head, tail, head, and tail. And A1 is equal to head, A2 is equal to tail, and A3 is equal to head, tail, head. So, can I write S is equal to A1 union A2 union A3? Tell me.
Yes, sir.
Can I write S is equal to A1 union
Yes,
A2
sir.
union A3? One thing. And the second thing, if I toss two coins, either A1 will happen or A2 will happen or A3 will happen. Am I correct? If
Yes,
I
sir.
toss two coins, if I toss two coins, either A1 will happen or A2 will happen or A3 will happen. The events A1, A2, A3 are these events are exhaustive events. So now, can anyone tell me? Can I say? Suppose this is one example I have given. Suppose another example I am giving to you. Suppose I am throwing a dice. What is my sample space? If I throw a
1, 2,
die,
3, 4, 5.
what is
So 1 to 6.
1, 2, 3, up to 4, 5, and 6. Okay, very good. Now suppose A1 is equal to A1 is equal to 1, 2. A2 is equal to 3, 4. A3 is equal to 5, 6. And A4 is equal to 1, 3, and 5. Now my question, can I say S is equal to A1 union A2 union A3 union A4? Can I say this?
Yes, sir.
Yes,
Yes, sir.
Yes,
Yes,
sir.
sir, you may say this.
So can I say this is the example of exhaustive events?
Yes, sir.
Yes, sir.
Okay. Can I say this is a pairwise disjoint event?
No, sir.
Yes, sir.
No,
Yes,
sir.
Yes,
Because
yes.
two and
Exactly.
But
If you
one
take
has
the
an
intersection of, A1 and A4, is it coming 5? A1
No,
and
sir.
A4?
No, sir.
it's
One
coming
आएगा.
1.
No, sir.
One.
Exactly. But if you are taking this example, can I say this is a pairwise disjoint event?
Yes, sir.
Yes, sir. Yes, sir.
Yes.
Yes, sir.
So therefore, the event may be exhaustive, but A1, A2, A3 may be pairwise disjoint, maybe pairwise not disjoint. So there are two cases. So is it okay for everyone? Whatever I'm trying to say, please tell me.
Yes,
The
sir.
event may be exhaustive. The event may be exhaustive. That is no problem. But I am trying to say that the A1 into A1, AN, that may be pairwise disjoint, that may not be pairwise disjoint. That I am to say. Like for this example, it's an example of pairwise disjoint. Observe, it's a pairwise disjoint event. That's why I take the same example whenever I discuss pairwise disjoint event. But whenever I am moving to this example, whenever I am throwing a die, means die problem, when a dice actually, sorry, die problem. So whenever I am throwing a die, so in this case, I have denoted A1 this, A2 this, A3 this, A4 this. But S is equal to A1 union, A2 union, A3 union, A4. That's okay, fine. But I cannot say AI intersection AJ is equal to 5 for IJ belongs to 1, 2, 3, 4. That I cannot say. So in this case, that is not pairwise disjoint, but it's an exhaustive event. So is it okay for everyone? Please tell me. Is it fine
Yes,
for
sir.
all?
Okay, sir. Fine, sir.
I'm just calling students' name actually. Chandan, is it fine?
Fine, sir.
Okay. Saurabh, is it
Yes,
fine,
sir.
Saurabh? Okay.
Yes, sir.
Abhijit,
Yes, sir. Fine.
Trisha,
Yes, sir. Fine, sir.
okay. Surya, is it fine?
Yes, sir. Fine, sir.
Okay, fine. So just here I am. Now I am just going to the next. That is, they have given like in this way. Now, equally likely sample points. That is another important thing. Equally likely sample points means, first I'm writing. Equally likely sample points. Equally likely sample points. Okay. Okay. So to tell me, suppose you are tossing two coins. Okay. So obviously the sample space S becomes head head. I am just writing head head tail tail head and tail tail. Obviously this is my sample space. So now suppose I am tossing two coins. How many times? Suppose I am tossing two coins 100 times. Suppose I am tossing two coins 100 times. Now I am asking to anyone, can I say at 81st time, at the 81th time, I will get tail? Can I say this?
No,
Yes,
sir.
No,
sir.
sir.
No, sir.
No, I
No,
can't
sir.
say.
No, sir.
I can't say. Because means if I'm asking to you at 81st time, can I get tail? The answer is no, because you cannot predict it. You cannot say it. Exactly what type of outcome you can expect, that you cannot say. But you know that all the event points are equally possible. I mean, either head can come, or head tail can come, or tail head can come, or tail tail can come. Can you say out of 100 times, there is a 99 times only head tail will come? Can you say me this?
No, sir.
No, sir.
No, sir.
So therefore,
No, sir.
all the points given head tail, tail tail, all the points are equally possible. All the points are equally possible. Therefore, you cannot say there is a chance that this is higher chance than this sample point, or this is high chance from the among the other sample points. That you cannot say. So all the sample points are equally possible whenever you are performing the observation or the investigation, whatever you are doing. So all the points are equally possible. That is I want to say. So you cannot say that only this point will occur many times. You cannot predict. So therefore, this type of scenario is known as equally likely sample points actually. Now, whatever they have mentioned, the sample points of a sample space are said to be equally likely if and only if one of them may not be expected rather than the other. So therefore, you cannot expect or you cannot predict that this is the happening of this head is higher than head tail tail head tail tail. You cannot say the happening of tail head is higher than head head tail tail tail. Is it fine for everyone, student? Whatever I'm trying to say. Please
Yes,
tell me.
sir.
Yes.
Yes, sir.
Exactly. So that is the case. Now we are going to study axioms of probability. In your course handout also you can check axioms. So in probability, we are going to study something axiom. Okay, interpretation axiom, some proposition that we are going to study. Okay, so tell me one thing. If A1, suppose A, not A1. Suppose A is your event. A is an event. If I am writing P of this, what is the meaning?
Probability
If
that
I
A
am
will
writing
come.
probability of A. So if I am writing probability of A is equal to 0.6, what is the meaning?
Out of
That-
like 1% chance, there is a probability of 0.6% that A can occur.
That means I can say
Difference
the
of A
student.
is 60%.
60%
I
chance
can
that
say
A will
60% chance.
chances.
Therefore, I can say there is a 60% chance that the event A will happen. Am I correct? There is a 60% chance that the event A will happen. That is the meaning of P of A is equal to 0.6. Okay. Can you tell me if I am writing P of A is equal to 0, what is the meaning?
Probability 0.
Impossible.
Rekha.
0%
There is
That
no
means
chance
I
that
can
A will
say
come.
there is no chance that the event A will happen, correct? Like throwing a die, throwing a die, throwing a die, and you are expecting to get 7. Is it possible?
No,
No,
sir.
sir.
Throwing a
sir.
die and
No,
you are
sir.
expecting to get 7. Not possible. So obviously P of A is equal to 0. So therefore, if I am writing P of A is equal to 0, that means it's a absurd event or impossible event. So that is cannot be possible. If I am writing P of A is equal to 1, that means
100%.
Probability of A is 1.
therefore the happening of the event A is going to
Sure.
happen surely or definitely. Am I correct?
Yes, sir.
Definitely. Definitely. Okay. Surely or definitely. P of A is equal to 1. That means you are saying the happening of the event A is definite or sure. Okay. So based on this, we are going to study some observation axioms. So axiom number 1. Axiom number 1, that for any probability, for any event A, we are writing P of A is always greater or equal to 0. For any event, probability of the event is always greater or equal to 0. Axiom number 2, probability of S is equal to, anyone can tell me? P of S is equal to
1.
1.
1. P of S is always equals to 1. Axiom number 3 that I am writing here. Axiom number 3. Axiom number 3. Axiom number 3. Suppose A1, A2, A3, and dot dot. These are and dot dot. Okay, many events. These are infinite sequence of pairwise disjoint event. These are infinite sequence of pairwise disjoint event. Okay, these are pairwise disjoint. Joint, pairwise disjoint events. Then probability of A1 union A2 union A3 union dot 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 is given by summation probability of A of I is equal to 1 to infinity. Is it fine for everyone? The last condition, A1, A2, A3, there are infinite sequence of pairwise disjoint event. This term is very important. pairwise disjoint event, then probability of A1 union A2 union A3 dot dot is given by summation I is equal to 1 to infinity probability of AI. Is it fine for everyone?
Yes, sir.
Please tell me. Now you see the axioms here given. Axiom 1. For any event A, P of A is always greater or equal to 0. Axiom number 2. P of S is always equals to 1. Axiom number 3. If A1, A2, A3 is an infinite collection of disjoint event, that is important. Pairwise disjoint. This term is important. Then you can write probability of A1 union A2 union A3 dot dot summation I is equal to 1 to infinity probability of AI. So now I am asking, suppose A1, A2, A3 are pairwise disjoint event. Okay, PDE in short I am writing. Pairwise disjoint event. What is this value? Can anyone tell me?
1.
This is what is the value? Probability of A1 union A2 union A3. Anyone? That is
1.
summation of summation of.
AI.
Am I correct? Please tell me. Because A1, A2, A3 are pairwise disjoint event. So I can write probability of A1 union A2 union A3 is equal to probability of A1 plus probability of A2 plus probability of A3. Pairwise disjoint means what? Now IAI intersection AJ is equal to, tell me, is equal to
5.
5.
5. For IJ belongs to 1 to 3 and I not is equal to J. Am I correct? Please tell me. Correct? So therefore
Yes, sir.
probability of A1 union A2 union is equal to summation of these. That is what? The probability of A1 plus probability of A2 plus probability of A3. We are going to use this. So just remember it, this line. Okay. So now, okay. Now we are going to study some propositions actually. Can anyone tell me what is probability of 5? Anyone? What is probability of 5?
So 1.
0.
0. Very good. Because 5 is anyone? Because 5 is
Null set.
Null set.
impossible.
MPK.
Impossible event, correct? Because 5 is impossible event. So therefore, P of 5 is equal to 0. How to show probability of any event is lesser equals to 1? Probability of A is lesser equals to 1. So whenever I have studied the complementary event, did I mention this line? Probability of A plus probability of A complement is equal to 1. Did I mention this? Probability A plus probability A complement is equal to 1. Correct? So in the first axiom, what I mentioned, tell me, for any event probability that is, tell me, that is
always greater than 0.
So can I say this? Probability of A lesser equals to this, that is equal to 1. Can I say this? Can I say this? Please tell me.
Yes, sir.
Yes,
Can
sir.
I say this?
So
Exactly. So therefore, for any event probability, there is a range. For any event, that always lies this. That you have to remember. For any probability, whenever I am checking the copies, means your senior batch and also one student find probability is for any particular example, he has written 27 by suppose it is they have written 12. So is it possible? Tell me.
No, sir.
no,
It
sir.
is no possible.
No, sir.
It
Yes.
is never possible. So if you are writing a probability, if you are getting an answer like 27 by 2, it is totally impossible. It is totally absurd. You
Greater
can't
than
get it because the range is given 0 to 1. So you can't write 27 by 12. Is it fine to everyone? Whatever I am trying to say? The examiner
Yes, sir.
will just check your answer. You are getting 27.2 and simply this. और उसको जरूरत नहीं कुछ चेक करने का. Whatever calculation you have done, whatever you are doing, they are not going to check anything. Because you have done 27 by 12. So it's a mistake. Because in the starting of the probability theory, we always tell that probability value always lies between this range. So how you can expect 27 by 12? So all of you getting my point? Whatever I'm trying to say, please tell me.
Yes, sir.
Yes, sir.
Exactly. So that you have to remember. Okay. Exams, the probability of phi is equal to 0, probability of A less than or equals to 1. And there is another proposition, probability of A plus probability of A complement, that is always equals to 1. That is a proposition actually. This line you have to remember. Extremely important. Everyone remember, everyone. Probability of A plus probability of A complement is 1. Everyone remember, everyone. Probability of A plus probability of A complement is equal to 1. It is needed up to your last chapter. It is needed up to your last chapter. So probability of A plus probability of A complement is always equals to 1. So whatever we are going to use, suppose, so probability of A complement will be what? Anyone? It will be 1 minus probability of A. That we are going to use very rapidly. Probability of A complement is equal to 1 minus probability of A. Remember this line. This line you have to remember. Okay. So now the next thing is coming. Okay, this thing. So now suppose A and B, two events. So have you studied, student, the so-called Venn diagram? Have you studied? Have you studied the Venn
The
diagram?
Venn diagram.
No, sir. Not yet.
First I'm asking everyone. Have you studied the Venn diagram?
Yes,
No,
sir.
sir.
Okay.
Yes, sir.
So with this belief, so I am just proceeding. So you have studied the Venn diagram. Suppose I am giving two pictures. And tell me, what about this value? Tell me. That is one picture. That is picture number 2. Tell me.
Picture number 2 is a disjoint one, and phi and like it have a picture number 1 has some intersection. So
Exactly. So
It is
in the
zero.
first case, A intersection B is not equal to phi. In the second example, in the second picture, A intersection B is equal to phi. So whenever A intersection B is equal to phi, what is this formula? Tell me, Bolo. What is this value? By the axiom number 3, tell me. That is
A plus B is the
If it is-
probability of A plus B.
exactly. That is probability of A plus probability of B. Okay. Now I am telling to everyone, whenever I am dealing with this picture, is this happening to here also?
No, sir.
Whatever you thinking, is it going to happen
No,
the
sir.
same thing whenever? No.
so
The answer
No,
is
sorry.
no. Exactly. So therefore, probability of A union B. If I am writing probability of A union B, that means which part? Tell me. That means the
A
total,
minus
am I
A
correct?
intersection B.
That means I am.
A minus A intersection B plus
Tell me A minus.
A intersection B plus B minus A intersection B.
So just I am trying to say A union B means what? Though I want to do the proof into two types, two direction. One is called geometrically, one is by theoretically. So first I am doing by geometrically. First you tell me probability of A union B. That means which part probability I am going to find. Tell me. That means
Except
this
A
part, am I
intersection
correct?
part.
Exactly. That means the whole part. Am I correct? This whole part. Exactly. So if I am writing probability of A plus
Yes, sir.
probability of B, if I am writing this one, if I am writing probability of A plus probability of B, that means how many times I have added this region? Can anyone tell me?
2.
2 times.
2 times.
2 times. So I have to do what? So I have to do,
2 times minus 2 times.
am I correct? Please tell me.
Yes, sir.
Yes,
Because
sir.
if you are doing probability of A plus probability of B, that means you are adding the portion 2 times. You are adding the portion 2 times. But theoretically what? You have to add the portion 1 time. Therefore, probability of A plus probability of B minus probability of A intersection. That is the geometrical interpretation. Now I am doing the proof, that is by theoretical. Now see the proof by theoretical. A and B, suppose. That is the intersection part. That is A intersection B, or I can write AB. Okay, I can write AB. I mentioned A intersection B means AB. So first you tell me one thing, students. Can I write A is equal to A minus AB plus AB? Can I write this?
Yes, sir.
All of you agree with me?
Yes,
or
sir.
not?
Yes,
Please
sir.
tell me.
Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
Now I am considering this is my A1 and this is my A2. Can I say A1 and A2 are disjoint event? Can I say A1 and A2 are disjoint event? Can I say?
Yes,
Yes,
sir.
sir.
Yes, sir.
Exactly. So probability of A, that means probability of A1 union A2. That means by axiom number 3, tell me, that is probability of A minus AB plus probability of AB. Am I correct? By axiom 3, by A3, axiom number 3. Can I write this one? Please tell me. Can I write this one?
Yes,
If
sir.
it is disjoint by the axiom number 3, I can write this probability of A minus AB plus probability of AB. Is Ritruputta there also? Ritruputta, are you there?
Yes, sir.
Is it fine?
Yes, sir. Okay,
Is it
sir.
fine?
I got it.
Okay. So
Fine, sir.
probability of A is equal to probability of A minus AB plus probability of AB actual. So now from this point of view, I can write now probability of A minus of AB, that is probability of A minus probability of AB. Okay, that I am getting. Now, that is for the A set I have done. Can I write similarly for the B set in this fashion? Probability of B minus AB is equal to probability of B minus probability of AB. Can I say this? Tell me, similarly like this?
Yes, sir.
Yes, sir.
Exactly. Now, total set is what? Total set is A union B. Now I am asking to everyone, can I write A union B is equal to A minus AB plus AB plus B minus AB? Can I write this fashion? Please tell me.
Yes, sir.
Yes, sir.
Yes, sir.
Exactly. Now, can I consider this is my A1, A2, and A3 such that A1, A2, A3 are disjoint even pairwise?
Yes, sir.
Sir.
Yes, sir.
Now, what about this formula? Tell me. I did na here. If it is a pairwise disjoint, I write na pairwise disjoint event, then probability of A1 union A2 union A3, that turns to be probability of A1 plus probability of A2 plus probability of A3. So obviously, what about this? Tell me. What about this? If I am writing A union B is equal to this part, then I can write this now, probability of A union B. That means probability of A minus AB plus probability of AB plus probability of B minus AB. Correct? Yes or no? Please tell me. From here I am writing, because these are pairwise disjoint event. That's why by axiom 3 I can write this line. Please tell me yes or no. Please tell me.
Yes, sir.
Am I correct? Exactly. But what about this? But what about this? What about this? That is probability of A minus probability of AB. Probability of A minus probability of AB plus probability of AB plus probability of B minus probability of AB. I can cancel one term. So whatever I am getting finally, probability of A plus probability of B minus probability of AB. Is it fine for everyone? Please tell me.
Yes, sir.
Is it fine for everyone? Exactly. So that thing I have established here. The probability of A union B is given by this way. So now if I am asking, suppose the proof they have given by the Venn diagram first they have established, then the corresponding proofs they have given actually. Okay. Now I am asking the proof. Suppose I have three events, A union B, union C. Can you prove this? What is the values coming? Can you prove this? Suppose this is your A part and this is your B part. Can you proceed from here? Please tell me.
So we can break in two parts and imply the same formula.
Exactly. So we are taking this is my A and this is my B. So what is the formula? Anyone? Bolo? Probability of A.
That's probability of
Tell me.
So probability A,
Probability of
probability of B, union
minus
C.
Am I correct?
B union C, yes, sir.
yes.
Can we break it?
We can again break
Can we
it from
break
the
it?
union part.
Exactly. So it is becomes probability of B plus probability of C minus probability of BC. Correct? Okay. Minus probability of, what about this part? Can anyone tell me? A intersection B union C. That means by set theory, it is distributive property. A intersection B,
And
Union?
union of A intersection C.
C. So I can write this part, A intersection B. So I can write AB, okay? AB union AC, okay? So now can I break this part? Now can I break this part? By taking this is my A, this is my B. Can I break this part? Please tell me. Can
Yes,
I
sir.
break this part? Exactly. So this becomes probability of A plus probability of B plus probability of C minus probability of BC. Okay. And this part minus anyone probability of AB plus
Yes, sir.
AC minus probability of. So it tell me one thing. A intersection B intersection A intersection C. What is the value? Can anyone tell me? What is this? A intersection B intersection A intersection C. That means A intersection B intersection C.
A
Am I correct?
intersection B intersection C. Yes, sir.
Therefore, it is ABC. Okay.
Yes, sir.
So right now I am writing probability of ABC. Okay. So if it is given in the bracket. So if I leave the bracket, then what will come? Anyone? If I leave the bracket, then it will be. Am I correct? Please tell me.
Minus.
Signs will reverse. The signs will reverse.
Minus, minus, and plus it will come. So ultimately becomes probability of A plus probability of B plus probability of C minus probability BC minus probability AB minus probability AC plus probability of ABC. Now you see the proof. They have done this. This proof they have done. That is the result. Probability of A plus probability of B plus probability of C minus probability AB minus probability BC minus probability CA plus probability of ABC actually. So is it fine for everyone? Please tell me yes or no.
Yes,
Yes,
sir.
Is the proof every? Okay, fine. Okay. So I am
Yes,
just
sir.
touching the problem. Should I touch the problem? I cannot finish the problem. Actually, this problem is little bigger. So should I go more or I should stop here actually? That choice is yours actually, student. Tell me. Is any other
Stop
class
here,
after
sir.
my class? Okay,
Yes,
okay,
sir.
fine.
DSC
I'm
class.
just stopping because I can't finish the example because it's a lengthy example and I have to tell many things whenever I want to discuss the example because it will take time. I can't finish like haphazardly. I can finish it. It will take time. Okay.
Sir,
So-
in next class we can discuss.
Tell me, bolo.
Sir, I was saying that so that we can next class we can discuss. Sir.
Exactly. Okay. Next class I will stay. I think the Thursday class. Okay.
Sir, can you share the notes, sir, which you are showing?
Yes, I will share the note. But my policy is that first I discuss whatever given in the PDF, then I will share, because if I share the PDF, it will create many misconception actually. Am I correct, student? Please tell me. If I share the
Yes,
note
sir.
first,
Yes, sir.
it will create many misconception actually. Someone will say it is going like this way, some wrong concept in your mind comes, another say wrong concept will go. So first I discuss, then I will share the PDF, because it is my own PDF I have prepared. Lots of time I have given for the preparation of this PDF, lots of time. Okay, so I'll share, don't worry it. I will, whenever I feel that I should share the PDF, I will definitely share. You can trust me. I'll share, don't worry, I'll share. So just give the attendance.
So can you please give the difference between the mutually exclusive and pairwise disjoint?
Mutually exclusive and pairwise disjoint event. Just one more time. Okay. That is where I am left actually. Properties of this, छोड़ो. अच्छा, exhaustive नहीं, pairwise disjoint. You are saying about this pairwise disjoint event and disjoint event or the mutually exclusive events.
Yes, sir.
Disjoint event or mutually exclusive event, we are dealing only for two events, A1 and A2. Is it fine? We are
Okay.
dealing the disjoint event or the mutually exclusive event only for two events, A1 and A2. But whenever we are dealing with pairwise disjoint events, the number is more than 2. Means A1, A2 up to AN. Is it fine for everyone, student? Tell me right now. We
Yes,
are dealing with more than 2. Then it becomes pairwise disjoint events actually. Okay, so here I am just logging. I will share the PDF. Don't think that sir will not share. Sir will share definitely. Whenever I feel that I should share the PDF right now, I will share. Don't worry. Whatever I am telling, you just keep notes so that you just read it. I will share the PDF. Don't worry. And our base book is Devor book. That is our base book. Do not forget it. Our base book is Devor book. Or sometimes we also check our textbook also. Whatever extra thing we have to cover, that we also check from our book actually. Don't worry about it. Mark it.
Sir, Shiv sir.
Yes, tell me. Tell me.
Sir, may I request you to tell us about the exercise, like all the things that you taught. So, like which exercise we should solve, like, to get idea.
Yes, I'll try to means some exercise problem. Means the problem that I have selected only, it is coming from the exercise problem. Still, I will check the exercise. I will try to solve some selected problems. Okay, from my side. After finishing chapter 2, I will go to the chapter that your exercise, and I will try to solve some problem from there. Okay.
Okay. Thank you, sir.
Okay. I'll try to solve. Don't worry. I will try to solve from the exercise problem, and also the problem that is given in the PDF. That I have selected the problem from the exercise actually. Okay. So 001 Avijit.
Yes, sir.
031.
Present, sir.
065.
Present, sir.
260.
Present, sir.
267.
Present, sir.
322.
Present, sir.
325.
Present, sir.
416. 416. Sulagnapati. Absent. 417.
Present, sir.
Present, sir.
473. 564.
Present, sir.
578.